Hey, the good thing is I don't speak Polish, so I have no idea what you're saying. So I am Tug, and Tugdual is my full name, but everybody is calling me Tug. It's a lot easier. As you can guess from my accent, I'm coming from France. So excuse my French or excuse my English. I'm working as a technical evangelist at MongoDB, working mainly with partners, but every time I can, I will join community and conferences. So I am here in Warsaw for Open Source Day, that is a 2-day conference in Marriott. I joined one of your members, Bolek, from Red Hat. He invited me to contact the Jug, and this is why I am here, and I'm quite happy to be here. And as you can see, I am myself a Jug leader in the city where I live, in Nantes. My job is really mainly meeting developers, explaining what MongoDB is, what NoSQL database is, how to use them, and so on, many things. Like many developers, at least I am working in this industry for 20 years, so I started as a relational developer, obviously. Developing with SQL, PL/SQL. I spent 9 years at Oracle. So I did switch from relational to NoSQL database, from relational to documents database as Mongo. And I have, let's say, 4 experience with NoSQL movement, I will say. One is coherence, when I was working at Oracle, so the data grid, in-memory data grid. Some experience with Bigtable. My pet project, this is a Java application deployed on App Engine using Bigtable. I used to work on another database, Couchbase. Now I'm at MongoDB. And also, next month I will be at the 30° conference in Krakow. I don't know how many of you will go there, where we'll do session on document design and a 2-hour workshop where people come with their laptop and I can learn more about. So it will be a good sequel to what we will talk about tonight. Talking about what we will talk, it depends on you guys, because I think I have 115 slides, and my goal is to not spend 115 slides with you. Do a quick introduction, then demonstration and discussion. So let's start by who is using MongoDB today? How many of you are using MongoDB? Okay, good, nobody. Oh, one guy, yeah, don't be shy. You should be proud of it instead of being shy. I am proud of it. And did you add some presentation about NoSQL technology globally? In this? No? Just a little bit? Okay. So this is why, the reason why I'm asking is just to make this presentation more interesting for you. I hope that at least it will be more interesting for you. So depending on the audience, because sometimes when I do this presentation, people have already played with Mongo or other NoSQL technology, so they don't necessarily need to have this first part. So why do we need another storage? What we have to keep in mind is relational database has been built in the 1970s, so they are built in the same time, more or less when I was born. And back at this moment, Kernighan and Ritchie that built the C language, we are working on this kind of computer. And one of the skills and one of the most interesting part of this is hardware was very, very, very expensive. It was very expensive to store data on disk, where in the same time, these two guys compared to this were probably very cheap. Hardware was very expensive, software developers or whatever you want to call them were cheap. Today it's the opposite. Cloud is cheap, hardware is cheap, but you are expensive. And I am even more expensive being in France, but so one of the challenges when the founder of relational or SQL was really to save space solving one problem, trying to expose this, a spreadsheet, in something that you can save on computer. So kind of doing a spreadsheet inside a table. But when you need more information, you can add more and more columns. But sometimes, because this is a person, needs to have relation with something else, for example, cars or address or kids. So you need to create a new table with a reference between them. So this is how kind of the stuff you build when you want to start to build your relational model. Quite easy. One table, another table, links between them, so relationship. You have very advanced programming language or query language with SQL to query, give me all the cars for this user. So it's nice, it's effective for storage, but it's not that easy to develop. And more importantly, if you work on a very large application, your model will look like that. And I guess everybody that is working in a big bank or insurance, so let's say an application that is more than 5 or 10 years old will be like that. So we can look at it differently. Suppose you want to build a car and you do an analysis, a concept, a model for the cars using a relational database. It will look this way. You will explode each part of your application in small records, and when you need to query it, give me my car. You need to find a way that you have to do all the queries, all the join, to build from all these little assets, one big asset. Obviously, it's kind of a big metaphor, but the idea is really the developer today has a very complex schema. Using Hibernate, JPA, or whatever persistence you want to use, ORM you want to use, you have some configuration, annotation that will hide this complexity for the user. It's working, but it's not the easiest way to work with your database, probably. But more importantly, suppose you have this in production, and you want to add new information in your database, new columns, new tables. This is where it starts to be challenging. How many of you can add a column or a table every time they want? So you discuss with your business user, or you have your project owner or product owner saying, okay, I want this new feature. And because of this new feature, you need to modify the schema. And very often it's a challenge. First, you have the DBA challenge. You have your DBA that must be happy, and most of the time he's not happy. Every time something changes in the database, he will be upset. And he's not upset because he doesn't like you. I hope that. He's upset because every time you modify the schema, it's a risk for him. His job is to keep the database performance fast, easy to manage, secure, and all this stuff. So every time we modify the schema, it's a risk. Sometimes you have to disable constraints, disable foreign keys, and sometimes have a hard time to reactivate them. So this is one of the reasons for the DBA. It's hard to accept all the modifications. So one part of the problem is hard to access the data, hard to modify, but also it's quite expensive. Relational database like Oracle, MySQL, SQL Server has been built to scale up, meaning every time you need more power, you need to buy bigger hardware. It's okay, it's working so far. Big mainframe from IBM, it's very, very expensive. But new applications, and if we look at the big internet companies, most of their data could not use a standard database. If you look at the volume of the size only of the index of Google in 2010, it was that big. And they don't want to buy the biggest IBM computer, and probably even the biggest IBM computer could not deal with that. They have to deal with cheap hardware, especially like Google. They build their own hardware to deal with that. Facebook, same kind of story. They have large volume of data. Even if they look at the biggest database, the number of transactions per second they can deal with could not be managed by out-of-the-box database. So what I'm saying is not that relational database or SQL database doesn't work. I'm just saying it's either expensive or complex. One example being Facebook, they use MySQL database. but they have engineers working only on the database server, creating a better MySQL cluster. I guess your job is not to build a database. Your job is to use a database for building application for your customer, building application for your startup, this kind of stuff. So the idea is really to work with your car, work with your business object directly. So one of the things we have built in MongoDB, instead of using tables, instead of using records, we use documents. So if we look at the same kind of view of the world, persons, people with cars, we will put everything in one single document. Paul has some cars. Paul, first name, last name, so on. Cars with a list of cars. So what is nice about it is if you look at the way you develop, the way you manipulate the data in your UI, you get everything in one single call, no join, no complex queries to do. You also have all the data in one single place. When you query that in memory, on disk, on the wire, you do that in one single operation. When you want to modify, when you want to delete, one single operation. And yes, it's oversimplistic in this specific use case because I'm putting all the user and cars in the same document. And maybe this car is used or owned by many people in different period of time. You have to think about the design. But my goal here is not to give you, yes, all the database will be designed this way if you have master detail relationship. But to give you an overview of the way you will be designing your application. So when you want to start to work with MongoDB, you don't start by creating an entity relation diagram with tables and join between tables. You start by, okay, what do I want to see on my screen? How do I access the data? Which operation I do? You focus on the application logic. If not the application logic, the way your application is dealing with the data, not the way you are storing it. You don't have a concept of, I don't want to duplicate, I should never duplicate the information in my database. I should never pre-calculate something in my database. That doesn't make sense. In many applications, it's okay if you store the data multiple times. If you print an order on an e-commerce platform, it's okay to have the username, the address, a list of items with their labels, and the calculated price. Because this will not change once it has been printed. It doesn't make sense to recalculate every time you want to print the order on screen. You don't necessarily have to do all the calculation every time. So, starting with this, in fact, the two founders of MongoDB have built startups, and they have been very successful with one of them that is well known is DoubleClick. DoubleClick is an ad management platform that has been bought by Google. And when they started a new project, they said, we want to build the best database to build application quickly and easily. So they say, let's use documents, and at the top of these documents, let's create a query language that allow me to do any type of queries. Specific queries to, okay, give me all Paul's cars, so first name equal Paul. Give me all the cars that has been founded between this date, with this date and this date. So do a calculation, do text search, do geolocalization, so geospatial queries. I will do that in a full demonstration just in a minute. So, full feature of database, and keeping in mind that we have built the database not to run on these big servers, but to be able to take many servers, community server, cloud infrastructure, and scale out. You need more machines, you need more storage, you need more CPU, add new VMs on Amazon, add new VMs on new small servers in your IT. Any questions so far? So, I talk about Google, I talk about Facebook, and we are not all Google and Facebook. But what is interesting to see is the technologies they used and defined in 2006, 2007, or even earlier in Amazon, Google, So big table kind of the stuff with Cassandra definition, DynamoDB has been good paper, architecture paper about what could be the new distributed database that has been used by MongoDB and other NoSQL engines to build a new database that are now used by enterprise. Insurance, bank, software in payroll, and human resources. And you can find many examples of applications in any type of enterprise. I will come back to some examples. So, MongoDB is, and it's very important to look at where does it fit in your IT. It's a general purpose database. That means almost everything you do with a relational database, you can do it with MongoDB. Obviously, you have to design your data differently. If you take each table and you take one document for each row and you take join between documents, it won't work. But if you think about it, you think about what will be the good design, we can say that 80% of the application you are building with relational database today could be built with MongoDB. That doesn't mean put your SQL database on the trash and build new application. It's just to give you that, yes, almost everything could be done. And open source and document. From a pure IT perspective, if you look at your global information system, the same way you have your relational database to directly serve data for your applications, you will put MongoDB in this place. And you can do some analytics until a specific point. Too much data, too much processing of the data. And sometimes you will need to work on an enterprise data warehouse, like you do Teradata and this kind of stuff. This is where Hadoop is coming in the picture. Usually you will see, for the very large database and very large data processing, a mix of MongoDB and Hadoop. When we talk about big data, quite often it's about a Hadoop integration. We are working together depending on the use case. And I will give you some examples. One thing, in case I forgot to mention, so a lot of download, but more importantly, we have interesting, I know it's not on your screen, just give me 1 second. One of the reasons MongoDB has been very successful in adoption, not only it's easy to use, fun to use, I hope you will see some fun when I do the demonstration, but you can be trained for free, you can learn it for free. You go there, universitymongodb.com, you register, and we have online training to help you to learn about how to use MongoDB. And we have trained more than 150,000 people this way. So let's go back a little bit, and I will do the demonstration. So, when the founder of MongoDB tried to do something very important where they choose how to implement. Because most of the NoSQL engine, most of the new databases have made some trade-off. They say, do we want to be close to the relational database focusing on feature, adding triggers and store procedures, but dealing with something different from relational, or being a very fast and easy to scale key value store in memory. So the choice of MongoDB try to have a very rich query engine and make the scalability easy and still have some good performances. Okay? So I like to switch between demonstration and slides, so I will do demonstration now. I will probably come back to some slide when I talk about deployment topologies or customer use case. Questions? Do you understand my English?
Yeah.
Okay. I was starting to be worried. I see if I have to learn Polish in 30 minutes, we are in trouble. So, can you hear me?
Yeah.
Okay. Let me switch to. Where is my mouse? Okay. Okay. So when you install MongoDB, so when you download MongoDB, you have a zip file, installer for Windows, RPM for Linux, and you have a list of binaries files. For start. When I don't type, I can. So today we will use two of them. One is MongoDaemon, it's a server, and Mongo, that is a client, the shell. And what I will do now is I will remove, in case I have some, all the data that I have in my default folder. So,
could you increase the text size?
Yes, I can. It will be a little hard for some documents, but we will do our best. So now I'm starting the database. Done. So unzip, start, it's done. It's listen on one specific port. It gives you, this is where my data will be. You can choose a location and so on. So now I have another window, and I will connect with my client. I am connected with the client. And one of the key points of MongoDB is to ease the development. That means no need to create database, to create schema, to create tables. Just start to save data. So let's say I want to use Varso database. Done. And if I show DBs, I don't have any database. I have admin or local that are for internal administration. I don't have Varso or Warso database yet. But let's create now db.user.insert. And I told you that we use JSON documents to store the data. So let's create name, age, and I will mix stuff just because it's confusing. It's nice when it's confusing, no? And date, new date, and that's it. So what I am doing here, I am inserting in something called user. The user is a collection of documents. If you want to match that to your relational mind, it will be the equivalent of a table. Save. So I have saved one document.
Why do you have age in brackets and name without brackets?
Good. So I give you 1 second and I answer the question. DB users find one. I have only one in my database. Done. So 2 things happening here, or 3 things happening here. So user collection has been created. Varso database has been created. And I insert a document that contains name, age, date, that is the date. So while here I have what is this?
Brackets.
Yeah, brackets or quotes. I have quotes or no quotes. Here I have quotes, no quotes. It's an integer, it's a date. And if you look at this, we have quotes all over the place. So 2 reasons for that. This, it's a JSON document. Do you know JSON? Mm-hmm. JavaScript object notation. In the specification of JSON documents, you need to have quotes in the attribute's name. On the value, it depends on the type of your data. If it's a string, you need it. If it's an integer or a number, you don't need it. So the reason why I can do whatever I want here, it's because it's a JavaScript engine that I use to insert. And as you know, JavaScript, you can do almost everything. So this is why I like to play with that and insert stuff. So what is interesting now is we have created one document. I can print it, but I can also, obviously, try to create a new one. So I have created a second document, and what I do now, I will create with my idea. I will say I want to have a specific idea, and this is name C. okay? Underscore ID is the primary key of my collection. If I try to do another one, I have an exception saying duplicate key. So you don't have a lot of constraints inside the database, but one of them, the underscore ID should be unique, and you can create your own index saying you want to have unique value. Also, what is interesting now, I have DB, user .find, and I will use pretty just to print it. I have 3 documents, 1, 2, 3. One of them has the ID. They all have the same fields. But let's say I want to add a new document, and I will use insert. But this time, I will use name. Of my son, page 12, and skills. It's not that good, but it's very good in Minecraft. So if I print them, what is quite interesting here is I have added a new document that has a different schema. When I say schema, it's not something that the database is validating, it's something your application is responsible of. So here it's my v1 of my application. I have name, age, and date. In v1.1, my marketing team say, oh, I want to add skills to some users. So I add the field, it's saved. And suppose that all my users, because they are part of the same application, need to be gamers. So what I can do, is I can do an update, and I will say take all documents. I will see this first criteria in a minute. What do you want to update? I want to push a new value in the skills. Push. What do you want to push? You see JSON, push is a command. What do I want to update? I want to update skills, and I want to add gamers or gaming. And because I want to be sure that I update all the fields, all the documents that are here, I will do true. So I see that here that I have matched 4 documents using this filter, so all my documents. I have modified 4 documents, and I can even do an upsert. Depending on how complex is your query, you can dynamically create document when you need to. And if you look at that now, my document that I didn't have the skills attributes has been updated, creating the skill attributes, inserting a value into it. If we look at the last one, so I did a push that creates the attributes when it's not here. And the last one, I added a new value to the arrow. And what is nice about that, obviously you can put strings, but you can put complex JSON object here. And one of the stuff that is quite nice is, sorry for that. So if I want to do DB users,
can you write the new things on the top of the screen? We don't see the bottom of it.
Okay,
here.
I cannot, but what I will do, I will reduce my screen. Okay? Is it good from here?
Yeah.
What is it? Okay. db.users.find. So the way the find is working, by default, it looks at everything. Pretty is just a presentation in the shell, has nothing to do with the query itself, but the query will take first a filter. So if I say age equals 12, it will return me only the user equals to 12, with age equals to 12. If I say, okay, let's give me all when the age will be that lower than 30, I will have all the user with the age of lower than 30. So you see that you can do almost everything you want. not only I want that, but I want also all the users that are less than 30 years old, but also that are Java developers. So skills, Java, sorry. Skills, Java. Done. So you see, when I was talking about rich query engine, is not only you can do all the operation you want, but also you can manage the JSON documents. But suppose this document contains 200 fields, and what you are interested with is the ID of the document and the name of the user. You don't want to call the database, bring the 140 attributes, get back the attributes, and in your application say, oh, by the way, I only want to print this value. So what you can do projections. So the second field will be, I just want to have the name, so 1 will be true, and I want to have the ID, 1. Now I just call the server to give me only this. And if I want to hide something, I just put 0. And I have only the name. So calling the database, do a query, restrict the number of attributes I want to return from the database. Okay?
Are you able to insert only the name, just without skills and age?
I don't understand the question.
Just try to insert a new record,
Yeah?
and pass only the name.
Oh, yeah, sure. So, db.users.insert. So here I have to do a db.users.find. And you see it's here. So I didn't mention what is this weird numbers or weird string. When you don't specify, so once again, the goal of MongoDB is to ease the development. So if you don't specify any primary key or ID for your document, we do one for you. And this is a client doing one with multiple things: a timestamp, hash of the MAC address of your computer, the process ID, and a sequence, an incremental number, to be sure that it's unique on many multiple machines, multiple processes.
Auto-increment.
It's more than auto-increment, because one of the issues is we are on a distributed database, and more importantly, you may have many processes accessing this database.
Computer.
Yeah, it's computer generated.
So what happens when you
When you what?
no.
So if you specify it, as I did before, and I try to insert it again, you will fail. You will say a duplicate key. So far so good. So one of the key points here is, you see how easy it's to create and insert data in the database, to query the database. Just talking a little bit about what happens when you want to deploy it. Right now, I have one single process on my laptop and nothing else. If you want to scale out, what you will do, you will use sharding. And sharding, you will select a key or use a hash of a key. You choose how, where, on which criteria you want to distribute the data. And automatically, every time you add new machines, the data will be distributed. And I will give you a complete topology in 1 second. But this will only allow you to distribute data on one single server each time. That means if you stay like that and you lose this server, this specific data won't be available until the server is up again. This is why, in addition to sharding for scalability, we also provide replication for high availability. So automatically, when you start your database, if you want to add more information, to have a distributed and highly available database, you can start multiple processes and make them as part of the same replica set. So it's what we call the replica set concept. You will have automatically one of them elected as a primary node on multiple secondaries. So you will write on the primary, it will be replicated on the secondary. And if you lose one node, for whatever reason, and one of the existing nodes will be promoted as primary again. So like that, you never lose any data, you never lose, your database globally is always available. And one very interesting part about that is you can do it's my plan for tomorrow. So this is used by DBAs or system administrator also when they want to do migration. They want to update, change the hardware, change the operating system version, change the version of the database. What do you do in this case? You stop this one, update, change the machine, update the operating system, update MongoDB, restart it. It's transparent for the system. Then when you arrive to the primary node, you just say, I don't want to be a primary anymore, so another one will be primary, and you do the upgrade. So today you can do that manually, and we have now automations that allow you to do that automatically on a large cluster. Why? Because a typical deployment will be this kind of deployment. Let's go to the big one here. So your application is connected to your database using a driver. I will come to that in a minute. So Java, C#, whatever you want to use. And it doesn't know about everything. It doesn't know how many nodes do you have in your database. Your application doesn't have to know what is the topology of the cluster. You don't have, if you want to remove nodes or add new nodes to your database, to change your application. Usually what's happening is your application in the configuration will know about one or two or three what we call MongoS or query router. Why 2 or 3 or more is just because if you are connected to only one, when you try to connect, if this one is not available, you will fail. If you just specify at least 2 in your configuration, if this one is dead, automatically it will go there and it will know about everything. So what's happening when you connect to the MongoDB from your application, your driver, either depending on the configuration, your driver or this knows about everything. It knows about all the cluster topology. If you add or remove node, it's transparent for your application. This is why we talk about easy scalability, easy high availability. Compared to what you have to do in a relational world to do partitioning or to do replication, it's a lot easier. And remember that all these little blocks could be installed on multiple machines, multiple VMs. We have 30% of the customer. When I talk about customer, most of the time I will talk about people that are buying subscriptions, so support MongoDB. And why I'm talking about that, it's because you have so many deployments that are on community, we don't know what they do with the product. But we know that in our install base of customer, 30% are working on Amazon, so cloud deployment. So this is what I have done. When you want to develop, you need a driver. You need to be able to work with a specific language. I guess most of us are doing Java, right? Which language do you use besides Java? Sorry? Ruby? PHP? C#, okay, so many of them. So far, everything is in the official supported languages. This is the ones that are developed, maintained, and supported by MongoDB. But in addition to that, we have other languages, like R, MATLAB, D. I don't know what D is. If you want to write a COBOL driver, you can. What is interesting is what we do is usually community is building the driver, and depending on the success and the adoption, we move it to something we support. This is what happened to the Go driver, the Go language from Google. It's used a lot. It's used more and more because it's very efficient when you have to do concurrency access to large multi-threaded application injecting a lot of data. It's hard for me to tell you which language is the most used. I will say in the enterprise, if we go back here, it's definitively Java first. Java is the most used. .NET also, so C#. But for many cases, they are also using Python, Perl, and PHP, depending on the application, depending on where you are. Many of the injectors or transformation of data has been built on Python, then the application is built on Java. And we see more and more Scala, not directly, but with the Play framework. Do you know the Play framework? Yeah, so that is now based on Scala. And you heard about LAMP, Linux, Apache, MySQL, and PHP. It's funny because if you, at the beginning of Node.js, the only driver for a database that exists was MongoDB. So the default language, or the default database for Node.js at the beginning was MongoDB. So this is why some people have built something called Min, the Min stack. Just for your personal culture, it's quite... Min for Mongo, ExpressJS, AngularJS, and Node.js. It's kind of the lamp of the 21st century. So let's look at some Java code then.
So if we look at it, is
Could you turn on presentation mode?
I don't even know how to
Say,
provide it.
maybe view or edit and presentation.
View.
Or view or edit.
Okay. Okay, so I'm lost now.
The shortcuts are still working, so we can
Just command N1. How do I move away from that?
Escape as
Escape.
I don't imagine.
in view there should be exit.
So I will zoom when it's needed. What I do for my presentation is this.
Okay.
So
the way we work with a driver, so this is a default driver. This is equivalent of JDBC of MongoDB. It doesn't use any object relational mapping, object document mapping, because we are not in relational. But the way it works is you connect to your database, and here you can put multiple things, either the host name or no host name, because you will use localhost by default. You can put a list of cluster of nodes, depending on with or without security. Then I will choose a database. I will, what I will do, I will choose an order. Okay. So connect to e-commerce database, get a collection, exactly like I did in my shell. Then I will create DB objects. DB objects are the objects you're manipulating with MongoDB in Java. Why not simple class and JSON? Simple class will be mapping, and JSON, remember that JSON will be, you will lose some type, and I will come back to that in a minute. Creating an order with customer name, a date, get this object, it's just returning the object, so it's a builder. Doing the same with an item, add the item to the list, same here. And what is key here is Here you have a double, here you have an integer. And we will keep that inside the database. In JavaScript, so in JSON, you don't have, you just have double. One of the benefits of MongoDB, when you use a driver, we keep some type. We have added some type to JSON. How it's done? Simply using something called bison. So bison is just a binary JSON. Internally, inside the database on disk, inside the database on memory, on the wire, inside the driver, we don't manipulate a big JSON string, we manipulate these kind of structures. So not only it allows us to work with specific types, but also it gives us an efficient way to do scannability, scanning of the document. When I did these projections, give me only the name of a document. So you have a large document and you want only some fields. One of the benefits is you know the size, so you can navigate in the document and jump to the next field inside the database instead of having to parse everything. So it's more efficient for parsing. It's more efficient not to store as a size, but to store as a type. Because when you will use an integer 32, it will take only 32 bits. And the disk and in memory. So let's execute this. So the nice part, it's supposed to work. It doesn't. Oh yes, I'm not. I'm working on a patch. Let's run this. And let's go to my database now. So I do show DBs. I see Varso, that was the database that I have built for the first demonstration. I see e-commerce, that is the database I just used. Use e-commerce, show collections, and I see orders. This is what I have just built in my Java programs. How do I bring it back to my screen? Crap. Right. Okay, it's better. So, if you see here, get DB e-commerce, get collection order, as soon as I put the save here at the end, it will create the DB. So if I do db.orders.find.pretty, I have a full document, which just go up. And it's an opportunity for me to talk about document design. I won't go in a 2-hour document design training kind of stuff, but if you see how I build the stuff, ID, adding one item, complex object, total. It's really the opposite of what you are doing in a relational database. In a relational database, first, you don't do that. First, you don't put everything in the source. Secondly, you don't put everything in the part. The reason why you will change your mindset, it's once again because this, most of the time, it will not change. When the order is done, it's saved, it has been printed, it has been sent to your customer, and most of the time when you will access this specific document, you want everything. Then, depending on your application, you can say, do I really want to have the customer name or the customer address here? Do I want to have the credit card number here or whatever? It's really depending on your application. But think totally differently about the way you want to design your application. And do not hesitate to do calculation when you are saving. It doesn't make sense to do a complex, yes, it hibernates, so it's not complex. It doesn't make sense to do a complex join on calculation every time you want to print it. So this is a big, big difference in the way you are building applications. Okay? So, I will talking more about Java, it would be interesting to. Yeah. So most of the time myself, when I work on when I work in Java, I'm using the Java driver directly. But I think the big difference between you guys and me, I am not building enterprise application. I am building enterprise demonstration. And it's a big difference in the way you have to maintain the code and so on. So you have to choose what is the best for your application. What I like about the Mongo driver, it gives you access to everything in a simple way, but you have to write a lot of code. So people have built API or framework at the top of it, and I will only talk about the Java ecosystem. You have the same in PHP, you have the same in JavaScript, you have the same probably in C# and so on. So the driver, it's what I told you in a minute. And one of the responsibility of the driver is to take a Java object and move it to Bison and keeping the good type. If we look in the types that are manipulating with the Bison object, you will see that you have doubles, integer, object ID, or you have an object ID when you don't specify the type yourself. And the code is what I showed you. Morphia, it's obviously based on the driver, and it gives you a simple mapping way to work with the database. Annotation with the ID, property customer, and when you want to save it, you create a data store on the Mongo database, e-commerce, and you save. So what is interesting here, you have your application schema kind of stuff. Because inside the database, you can store everything you want. But here, this specific class is your schema for your application. This is where the truth is if you are working with it. So if you need to do governance or master data management, this kind of stuff, to know what is the schema of my database, of my application, sorry, a part of the truth is inside your application. And we'll come back to queries. So we replace the ORM, the object relational mapping term, by ODM, object document mapping. And you have many APIs that you can use at the top. One other is Spring Data. Do you use Spring and Spring Data? Yeah. So it's another library coming obviously from Spring, giving you access to many data sources. And one of the main reasons I'm using that with MongoDB, developer, it's when they need in the same application to share access and have the kind of same API to access relational database, NoSQL database, Mongo, caching layers, key value stores, and so on. And it's nice because you have a common layer, you have access to connection pools the same way, and so on. So as a developer, it makes the life easy. And it's especially interesting in some use cases where you have a part of the data that are stored in the relational database and a part of the data that will be stored in MongoDB. Let me give you an example. Is one of the mobile phone company in France has a product catalog that defines all the services you can buy. So not the application, but you can buy SMS subscriptions to soccer result or whatever, politician, whatever stuff you want. And they have this product catalog. You are on the mobile, you can subscribe to I want the SMS about sport or about soccer and so on and so on. And the marketing team said to the development team, said, I want to add more services to this. Not more services, more features to this. Like, I want users to be able to comment on rating the service. The same way you are in an app store, when you can add rate this application or rate this or put a comment, they wanted to do that. The issue is this big product catalog, the service product catalog, is based on a product they bought, and they don't have access to the database schema. They have, but as soon as they modify it, they will lose support. So instead of hacking something in the relational database, they have built a MongoDB database that synchronizes automatically with MQs, private MQs, a subset of the data you have in the database inside MongoDB. So every time you modify something about the product catalog itself, it's inside the relational database. Every time you need to access social kind of value, it's in MongoDB. And what they have built a layer at the top of that using Spring Data just to access the two in an easy way. And what is nice in this case, every time the marketing wants new value, new tags, new metadata at the top of their services, they can use this database. So they give flexibility. So Spring Data was used for this. Spring Data, same annotation, and then you have specific API to do query. It really depends on the framework you use. Django is another Java driver that instead of using a Java query builder with very long queries, you use exactly the same syntax that what you have when you work with the shell. It's for people that are used to work with the shell. So mapping, same when you save at the end, but if you look at here, you will do find string with a quantity 2 that you pass as a parameter in the dash. Fields will be the projection, so ID 0, date equal 1, customer equal 1. So and you will map that in the order class. So it's really giving the same experience. Hibernate or GM, object grid mapping. Using JPA or Hibernate on a non-relational database, probably not the best idea.
Does it work?
It works for if you don't have queries. And I kind of, so I put some annotation, but here it's really what you have in JPA, Java Persistent API. So you generators, ID, columns, you see columns. And you get the persistence context, and to get the entity manager, you persist and you do everything you need to. So I try to kind of explain quickly, if you really want to learn MongoDB, the best will be to start with a driver. So I will say the only thing that I don't like about it, that we could improve a lot, it's you have to write a lot of builder, on add, on push, and so kind of key value mapping kind of experience. So it's not the best for the developers, but we are working on a new version of it. But it's a nice way to understand how to interact with MongoDB. Morphia has been developed by the community, but we now support and developing. So simple mapping. This is a nice ODM stuff. Very simple at the top of the driver. Spring Data is a lot more rich. It's a richer experience because of multiple data sources you can use, because of the fact that you can also use templating. So the name of the method will automatically generate a good query to your database. So really great for people with Spring experience, as you can guess. Django, really fun for the query language farm, so I would have to check the shell of farms. And Hibernate or GM, it's too early, I guess. And I don't think it's the best way to learn a NoSQL database. And for sure, it's not the best way to learn MongoDB as a document database, because the complexity of MongoDB doesn't come from the code, doesn't come from the query language, it comes from the document design. So if you design kind of using your entities, you will end with a very relational model at the end that probably doesn't scale very well. So the way I like to position it, it's a good bullet, it's a good checkbox. People will ask me, do you support Hibernate? Oh, yes. Do you use Hibernate? Oh, no. It could work in some cases, but try to avoid if you have a real project to do it. Maybe if you want to learn quickly, generate your database, look at it, but it's probably not the best design. So, I talk until which time we are? It's 7:20.
We still have half an hour.
Okay. So, we see the installation, we see basic operation, Java driver, basic Java driver. I didn't show you all the codes, but you can guess that you can do almost everything I have done on the shell. I want to show you aggregation framework. How do you analytics at the top of your database. And I want to do full text search, demonstration, and geo queries. Like that, we see everything. So, for this, to generate more data, what I have here is I have a small application. And this application, what it does, like many people doing NoSQL, big data, whatever stuff, we use Twitter as a data source. Not surprising. So for this, I use Python, and I use Python for two reasons. First, because it was fun, but also because what I want to do is I want to do sentiment analysis at the top of MongoDB. So for this, I have built an application that is on my GitHub repository, and explaining what you have to do. And what I have to do first, I have to create some data. So like that, you check out the code, you install Node.js, Python, and everything you need. So use Twitter database, and let's create some data. These specific data are just, if you look at it, brand, Apple, MongoDB, Amazon, Google, and Ford, that I use to choose on Twitter which keyword I want to use. Okay? So I will run my Python. So it's connecting to the database, calling Twitter, and every time it will look for Apple, MongoDB, Amazon, or Google, and so on. And it will save that inside MongoDB. But in the same time, before saving it, it will call the get sentiment, the gets polarity score on the text. So it gets the Twitter text, it gives a sentiment that I save in another document. I could have saved in the tweet if I want, but in this case, to do calculation, I just keep it simple. So now if I look in my database, use Twitter, show collections, I have config, that is a list of words, messages, that is what is injected, sentiment is a calculation. So db sentiments find one. So I see the tweet ID here, it's on Amazon, on positive or negative, so it's kind of neutral here, and we see that here. So every time I inject a message, I do that. If you don't know what is a tweet, this is a tweet. 140 characters, 100 attributes. So it's a nice JSON document. So based on that, what I have built, I built a Node.js API, a REST API. You could use any Java application or whatever. And I use AngularJS to consume it. My goal is not to give you an Angular or Node.js demonstration in detail, but just to show you the result of the application. So you will see that I am injecting documents. I put manual refresh, it was just to show that. Every time we will add new documents, you will see it. And the way the application is built is when you want to see a tweet, at the end I have a small REST API that shows me the documents. So I put that inside a document ID and I put the full, because like that I can extend it if I want. Oh no, I'm giving a stupid answer here. This is a document, because at the end what I have, you won't see it. Sorry for people in the back. So what I do at the end is I show you the query that I use to generate this REST API code. It's just because I use this application to do teaching and discussion with developers. So my application looks this way now. So I'm injecting stuff, I can show that, and what is interesting is, I should have stuff with images somewhere, okay, here I have images, so it's okay. it's kind of dangerous to do demonstration with Twitter because sometimes you are surprised by the picture or the text. This is why I use Amazon, Apple, and if you don't put any filter, you never want to do a public demonstration. So suppose this is not okay for work because it's a porn image or whatever you want. So what is nice about the way you develop your application, you can quickly extend your application to add new features. For example, what I want is I want to modify this tweet to add a comment saying that it's not suitable for work. So let's look at the tweet itself. Okay, API. This is my tweet. Nothing special. What I will do here is I will modify the document, called pic, not suitable for work. Okay, it's saved. At least it's supposed to be saved. If you refresh, it's saved. So I use Angular binding. You have Angular demonstration here? Some time ago, yeah. So let's open the tweet now. And if you look somewhere, so automatically I modify my schema and I modify the document, this document only to add this field of these attributes. So it's interesting because you can extend your schema without modifying the 2,000 documents you have or the 2 million documents you have. Yeah?
So these fields burned?
No. If you look here, so it's just after place, okay? I have the same, this is why I open it twice. You see? And what did I send to the database when I did this update? It's not what I sent. Oh yeah, because I refreshed. Let me just, I lost my mouse. Okay. So let's save it again, just to show you the query. So forget about the sort. The sort is, I do a final modify. That means I just want to be sure that nobody else is modifying the same field as I do. Field, not the document. You can modify the document, but not the field. And I do an update, adding these new attributes. New is to do an upsert, but I don't need the new here. Okay? So you see, we automatically modify the schema of a document. So in this specific case, it's okay to have multiple documents talking about tweets having totally different schemas, because the core of your application is dealing with tweets and hashtags and so on. So, okay, starting to starve. One of the key stuff you need to think about when you build your application is that the fact that it's very easy to modify, to add values, and focus on your features. And if you need, in this case it would be totally stupid, but if all the documents need this field, you have to do a small routine to update all the fields, but you see an update with a parameter and it's done. This is how I have added gaming to the array before. So one of the stuff we need when we talk about database, it's create, good, update, good, delete, you trust me, we can delete stuff. Query, but you want also to be some calculation, some aggregation. So how do you do that? You can count stuff in the database, it's quite easy. So if I want to count, can you see my screen? db.message count, 40,000 and so on and so on. But if I want, if you look at the tags, do we some tags here? We don't see this. Or mentions. So if you look at the document and you know that you have tags, hashtags, a name, and you want to count the number of tags and which tags are the most popular, how do you do that? You don't have group by having by default in the file. What you will be using is what we call the aggregation framework. So as a starting point, before going to the tweet demonstration, I will do that with the Twitter demonstration. So DB with the user, DB find. Right. Okay, so I have tags. You see, here I have tags. The skills. Which skill is the most used in my database? So give me the top 3 skills that I have in my database. So for that, I will use another. So I will do db users.aggregate. This is the command you use to do the calculation. And the aggregate is a pipeline of operations. So it's multiple operations you want to do the one after the other. But if you look at my documents, here, I have tags, or I have inside an array. So gaming is here, but you have Java and Minecraft. So to be able to count, the first thing I have to do a kind of exploding all the tags to have one document for each tag to be able to count after. So we have a command for that, and the command for that is inside the aggregation pipeline. You do unwind of skills. And if you look at the result,
there's missing.
oh yeah, I'm missing food. Here you have to, sometimes you have to put, when you do a reference to a document. Okay, so now you see, for example, for the last one, for Briac, he has skills Java, skills Minecraft, skills gaming. So we explode that, and it's just a query, okay? It doesn't save anything, it's a cursor. So the next stuff that I want to do, I want to group by tags, or group by skill. So it's a pipeline, so next step, so it's a JSON document, it's a JSON array. I want to group. So you have to learn the syntax, okay? Get the concept, and I will group on what? I will group on skills. And what I want to do, I want to count. So the name of my field will be count. And I want to do the sum for each. Here I don't use a numerical value because I don't have, but this is if you want to calculate the total price of an order or something, you will put here you will put, for example, the price that is inside the document. So if I do this, now you see I have Minecraft 1, Java 1, Gaming 4. The next step will be sorting and limiting. So sort by what? By count. It will be -1 because I want to start with the biggest one. You see? And if I want to, for example, the top 3, but I have only 3 now, so it's not a good example, so I will do limit 2. It will be the top 2. It's done. And what is interesting here is we execute the query all the time, okay? We do the aggregation. If we are in a cluster, we will distribute the query on all the nodes, do the calculation on all the nodes, get back that on the query router, and do the aggregation and calculation on the query router. If you have billions of documents, it can take some time. And most of the time, if you talk about this, Do you really need this value in real time? Is it okay if you do that every 5 minutes to know what is the biggest tags in your database? It depends on your application. What is the biggest tag on Twitter? Now, I can look at it, but I'm not sure this is the biggest tag on Twitter. So what we have done, in case you want to kind of pre-calculate and put that in the database to be reused, you can do, for example, I will remove that, and this is new, you do a out, and you will say, I can put that in results, and you can put any name, it's a collection name, so I will put Karek, just to show you, we can put every name. In this case, you will execute the aggregation as fast as possible, but you will save stuff in .find, and I have the result here. So you can say, okay, keep that for 5 minutes, create an index on this, on time to live. You can create an index on time to live in this collection, and after 5 minutes, this data will be deleted, so you can query again the stuff. So this is what I used to do this kind of report inside my database. So I have the top 100 tags from Amazon, from Twitter in my database, not on Twitter. It's what I have in my database. And I use exactly the same kind of stuff. It's unwind, group, projections to rename the field, sort, limit. And here it's calculated all every time.
I have a question.
Sure.
Did the driver give you the callback when the work is done?
So in this case, it's just in the current version. So the question was, do you have a callback when it's done? In Java driver right now, it's synchronous. We are working on an asynchronous way of working with that. Yeah?
And this output into new collection is in the future, in 2.6.
Yeah. It's new in 2.6. So $out is new in 2.6.
Okay.
Okay? Yeah?
So, is there some way to join collection actually? I have to ask this question.
Is it a
Ways to join collection somehow? So
do we have a way to join collection? And the answer is no.
because I guess in of course there are a couple of options. So
Yeah.
one would be there's a way to join collection, but another one answers also
So the reason why you don't, one of the reasons you don't have join is because when you are in a complex deployment, if you are on this, you cannot join here. You can, but you may have one document here, the next one here, the next one here, and the next one here. Your query will take forever. We already do some calculation, so everything we do calculation here, get back, calculation, get back. It's already expensive. So what most of people need when they want kind of join, they either embed the document inside the document when it's possible, or they just create a cursor, kind of old school way of doing it, creating a cursor here and calling gaming. It's exactly what I have done.
So it's you solve by scripting.
Yeah, it's inside your application. So it's exactly what I have done here. It's you have the tweet, and when I click here, I will go for all the tags with beauty. So most of the time you will write more code, but the code will be faster to write and faster to evolve inside your application. So what about full text? So if you look at this, ice cream, let's look for ice. I don't have anything. If I need to find something with ice, I have to either send a regex, regular expressions, in the string. But if you have sized a million of documents, it will be expensive because we cannot create index. So what we have done is use Twitter. Clear. And what we have to do is to create indexes. Obviously, on a normal database, when you know that you will query stuff, you will create indexes. Normal indexes, or full text indexes, or geospatial indexes. I didn't show you the index, but here I will just create message ensure index, and I will say, let me DB, I just have to remember what is the name of the field just to be sure. And one, I think it's text, but I just want to be sure. Text. You see it, text, source.
Yeah, third on the right.
You have it? You see it?
On the top.
Oh yeah, it's here. So what I will do is we'll db message dot find ensure index, and what I want to do is I want to create on the field text an index of type text. This is the field, the first one is the field, the second one is the type of the index. Here it's confusing, but so if you look at it, we have created an index. Now what I can do is look for, it's in Japanese, so it's kind of challenging. If I want to query it, db.message.find, what I want to find, I want to do a text search, and I want to search. We have done that to be prepared to have more options. And I have the result. Let's show the text, okay? Text 1. This is the text. And one of the benefits of that is chain 1. We are not careful about the case. You can do, for example, stars. I don't remember what is the text for that. And what is interesting also, let's find a text in English. So, okay, let's look for April. April. So we will have many of them. So do a count. 500. Okay, but I want everything that contains April but doesn't contain iPhone. Minus iPhone. I have this. So it's really a very simplistic full text. So what we do for you is we index all the names. So we reduce the stop words, we remove the stop words, we take singular, majuscule, the roots of the word that will be used for the search. And when you create the index and when you do queries, you can specify your language. So multi-language support also. This is important for the stop word because I guess in Polish, in English, and in French we have different stop words. Questions?
How indexes are stored? Also with true replicas?
So how indexes are stored? So first of all, they are built when you save, so it's consistent index, and they are B-trees on disk. And first on the primary node, then pushed, the data are pushed, in fact, the replication works and the index is updated on all the nodes. So we have exactly the same data all over the place. It's important because if you lose one node, you need to be able to have the... You, by default, you only write on primary and you read on primary also for consistency, but you can choose to read on secondary if you want for your application. It's important if you deploy the secondary, for example, we have a data center in Europe and we have another data center in America. You want to read the data faster from America, you can have secondary read, but be careful about the consistency. So the last demonstration that I want to show you, so we see aggregation framework, we see full text search, and I will talk a little bit about geospatial. Starting to be tired, sorry for that, guys. And girls. So about geospatial is the first thing is you have to store geographical information inside your database, and more importantly, you have to be able to query them. And we have sample application using that. Foursquare is based on MongoDB, maybe mobile application, credit card payment integration, mobile application for human resources. I can give you more examples if needed. So we use GeoJSON to store the information. GeoJSON is an open standard using JSON to define how do you represent geographical information. And you have different types. A simple point, you see. So this is my attributes, but this is the GeoJSON. Type, point, coordinates, longitude, latitude. It's the opposite of what we say usually. Don't ask me why, it's probably the way we do the index. But it's part of the GeoJSON specification. If you want to represent a string on a map, so you can have a multi-string also. If you want to represent a polygon, this is how you will do it. The little caveat here is the first point and the last point needs to be the same to close it. So you can build very, very, very complex polygon here. And what I have done is using open data. I capture some, I won't remember the site. But if you go on many public websites, probably in Poland, in US, in Europe, you have open data that you can grab that are maps. So what I have done here is I use, I will import, I hope I didn't delete everything. No, I think it's okay. So I will import some data, Mongo import. So it's a bison. I exported some data from my data. So now if you look at my database, I have imported data, show collections, and this collection contains airports and contains cities and states. And db.states.find one. So this is a Wyoming. Oh crap, it's a very simple state. You see, not that much point. Do you know the US map states?
Texas?
No, the Wyoming is this one. So it's almost a square. So it's not, I'm not lucky because when I do a find one, I always get this one. So if I do this, you will see that we have a lot bigger states. You see? So this is the definition of the state. I have installed something that is we have time for that? No. It's just a map viewer that is built at the top of GeoServer. It's a generic server that captures data from any format and allow you to map that on a map. So you will query MongoDB in this case. So if I want to find all the airports that are in a specific zone, so what I have to do is I will use this is so for example, if I want to find all the airports that are a specific state, I have the map of the state as a geopoint, as a polygon, this is this. And what I will set, I will geo-weaving, and I will use this geometry of the states, and it will give me all the points. So it will be my last demonstration. So you have to do, because we don't have join, we have to do a two-step operation. First, get the map. So let's get the map. I will use the first one that I showed you earlier. find one. Find name. And the polygon looks this way. Okay? Obviously you will have to build, I have not yet built a demo on that. So this is my polygon. What I want to do is, if I go here, db.airport.find1, what I have is, I have some information about the airport, and I have the point. That is in the log field. This is the name of the field. So what I have to do is find in the log field all the points that are in my polygon. So I will cheat a little, if you don't mind. And I will define that as a variable in my shell. var state equals, so it's just JavaScript. If I do state, this is geo, okay? Because since I am zooming a lot, let's take the query, and let's take the query, sorry guys. So lock in geo within with the polygon, and here I will take state. So you have to love brackets if you want to do JSON. Geometry equals state. And here it will be airport. Done. And if I want to show only the name will be property dot name equal 1. So I see the name, and you see you have a type. So what you can do, so you have municipal, regional, and suppose you are only interested by municipal. What you can do is you can join, so you can do a query that filter not only on geo, but also on another field. Let's say I want to do the log, but in addition to that, I want to have only the municipal stuff, and we have only the municipal stuff. So, and you can add full text search in the aggregation framework. You can add geos in the aggregation framework. So you can play with it. So. If you want to do it, you can do exactly what I have done. We have an enterprise edition when you go on MongoDB.com. So this is for people that want support, but it's an open source project with a community edition. So if you want to start, if you want to learn, you go to MongoDB.org, you download, you use it as much as you want. If you look at it, if you go to MongoDB deployment, if you look in product deployment MongoDB, you have a lot of sites. It's the one that accept to be on this zip, and you see this. Some of them are customer, most of them are just using MongoDB community edition. Our goal here is to have more and more developers using MongoDB, ideally with an enterprise edition, but it's an open source project, so you can use it. What we like for people using MongoDB community editions, when you do something cool with it, add you on this list. It's nice for the community. It's just, you just have to submit this form, or more importantly, go to some events and talk about what you do with MongoDB. And I hope next year when I go for open source day, we can discuss about what you have done with MongoDB. So do you have questions?
Yeah.
Okay.
So you mentioned that when you do the update of the field, there is this lock, like pessimistic locking, right, in SQL. So there cannot be a concurrent update, right?
Yeah. So, like any system, when you have to write on disk, you cannot write in the same time on the same thing. So the way we work is when you send an update, we have for few milliseconds, nanoseconds, depending on how your CPU, your memory is working, we will take your update, modify the value in memory. And for this specific moment of time, nobody can modify this database.
All database or just document or
Or
just
just the collection.
excuse me?
Just, no, the collection.
Just
Not the database, the database.
full database?
Yeah. Sorry?
Global lock.
Yeah.
No, because the reason why you are talking about global lock, it's because you are talking about the lock of the relational database. When you do a lock on the relational database, you open a transaction and you lock some resources. Depending on in Oracle database, it's at the record. In old DB2 version, it was at the page, specific number of record. In MongoDB, it's just a lock at the operating system on the file, in memory, on the memory map file, for the time that you receive the documents, change the attributes, give it back. So what does that mean? Does that mean 1 millisecond? Half of a millisecond? It depends on how much CPU and how much update you have. If you start to be, your system start to slow down, you have to monitor the stuff, and the way we do it. You just learn, we have a console to do that, but you can do it from here, Mongo Stat.
So if you have many concurrent updates, so the ones that fail. Yeah.
So nothing failed. It will wait. So what happens is, I have to reduce a little bit. Let's kill it just. You see here you have the lock percentage. Until this stuff is going further than 60%, you have no issue. You don't slow down your system. What happens if you slow down the system? Sorry?
Scale up.
Exactly. This is one of the metrics you have to look, or you can change hardware, but the easiest way is to scale out. So you will find on the internet many blog posts saying MongoDB doesn't scale, or MongoDB is slow. Yes, if like any system, if you don't monitor it, or if you don't understand how it works at a specific moment of time, you will have some issues. And it depends on how far. On these specific machines, I can insert at 30,000 operations per second. Inserting 30,000 without slowing down queries. It really depends on the type of application, the type of operation you are doing. So yes, we have logs inside the system, but there are logs, atomic logs on the operation you are doing on a specific document. So today it's on the DB stuff. This is the reason why I was thinking I have to remember. We are in 2.6 in production. We are currently working on the 2.7. So 2.7 is a development branch. We are on the 2.8, we will do the lock at the document level. So in this case, it will be a lot. Every time we reduce the concurrent stuff. It's all about trade-off, you know. Oracle is 40-year-old, we are 7-year-old, and we focus on developer experience first. One of the stuff that is very, very important to do is just look at even if you are not so it's at the top, it's all the commands and tools you have. Here on this specific page you have everything you have to look, and you have solutions to what you have to do when you start to have issues. So logs, for example, is a good example. Page fault, that means you don't have enough memory for your working set. So you save something, you get something, the stuff you just get has been pushed out of the memory because you insert another stuff so you do a lot of IOs. One other stuff, for example, that we will look in the context of replication or sharding will be the replication lag. How much time does it take for primary nodes to copy the data on the secondary nodes? So this is the stuff you monitor. MongoDB is a database. Yes, it's easy for development, but still you have to manage it, you have to monitor it. No magic here. It's if you're running with 1 or 2 million documents, you will never see any issue. But when you start to have hundreds of millions of documents or millions of users or transactions and this kind of stuff, yes, you have to deal with that. Other questions?
What about using MongoDB in Android or iOS?
No, you don't have.
Just
It's only, it's a server-side technology today.
it's kind of backend.
It's a backend, yeah. So you may have some people that have ported, because we have a Raspberry Pi distribution, but it's probably not the one you want to use in production. At least you can scale out, yes, for sure. And it's cheap to scale out.
So you're saying that data is stored in JSON files on the file system, right?
So, no.
Or this is just some way of working with databases. The data is stored different way.
So inside the database, it's stored at Bison. It's stored using the format that I showed you.
Okay, but still, these are text files, right?
Not really text files, because integers are stored in integers, and string are, no, it's not text file. It's not, you cannot look at the file, because we use specific blocks. You have many stuff you can look, for example. It's so DBAs will look at how the database is living. For example, what are the number of extents, so what is the not the partitions, what are the number of blocks you have in your data file, what is the number of index, what is the full size of the index on the file, on the data. So internally, you have to look it as a binary kind of content.
Okay. And if I would like to, I don't know, integrate MongoDB with desktop application, would it be possible? Or
yes, we have some people.
Some kind of crazy idea.
So the question is, can we use or can we integrate MongoDB with desktop application? So yes, we have people that do OEM. So they put that inside the same process. It's a C program, so you have to run it as it's a server, but you can embed it.
Okay.
Yesterday I was discussing with one of our partners that is doing workload injection on the stats they use. They use MongoDB to gather the data and to store the data. They use a single instance on the device as not as a main database, but as a database to do some work and quickly store the data. Then they push the data back. So it's more or less what you have to do. It's not desktop UI in this case. It's a process. But the database is associated to this process.
So do you let's say you write some data to MongoDB, do you write it through directly to this?
No, so way it works. So how does it work from memory to disk? So the way it's working is we use memory map file. So we don't manage memory on that. We let the operating system do it. So if we have to save a block, it's in memory, and we do the F-think to the disk. Yeah, the operating is dealing with that. In the very, very old version of MongoDB, it was the only way. And this was always memory map file to disk. But it's risky because you don't control exactly when it's saved on disk. So since 2.0, I think, I don't remember, but because now what we have a journal. That means we have the last operations. When you do the operation, it's saved on the file we manage. And from the journal is saved in memory map files and on disk. So if we kill the system, you don't lose data because you have checked that it's saved in this journal. You have options to say, do you want to wait until it's saved in journal? Do you want to wait, is it only in memory? Or do you want to wait, not only it's saved locally, but it's replicated also? This is the developer that will choose that. So thank you very much. I have some stickers. I don't know if I have stickers for everybody. I will check. If you want some. I will. One very important part is and this is really important. Remember my email in case it's either tug@MongoDB or Tugdual. If one day you have a project and you say, is it a good fit for MongoDB? You can drop me an email. And I will explain, obviously I am biased, okay? I will be tempted to say yes, but I will always explain why I'm saying yes or why I'm saying no. Because our goal as MongoDB community, and I'm not talking about the enterprise only, it's all the users of MongoDB, all the developers of MongoDB, it's to have successful projects. Because every time you have a new technology that fails in a project, we don't blame the developer, we don't blame the business user, we blame the new technology. So it's more important for us to take 15 minutes with you guys saying, okay, what is your project? Does it make sense to work with MongoDB on this project? And say no, instead of having you going to the project and a month later saying, oh, that sucks, I cannot use the product. So this is really important for us. And one of my responsibilities is to work with the community to help them to adopt the product.